Alright, now let's get on to trig ratios. So, when you are finding the sine, cos, or tan of an angle, we actually have a way to do this without using a calculator, but only for specific angles. So, as you can see down below, we have a table of values, but I will also show you guys how to do this using special triangles, which is still how I do it, even when I'm doing maths in uni. So, as you can see, we have our table of values here, but when you're using your special triangles to find the sine, cos, or tan of an angle, what you need to remember is what the actual triangles look like, and that's it. So, you need to remember the side lengths of the triangles and the angles. So, this here is going to be 30 degrees. This here is 60 degrees. Right? This is a right angle. So, looking at our side lengths, remember the longest side, the hypotenuse, is going to be 2. Our upright side is going to be root 3, and our bottom side is going to be 1. Now, how you can remember how these angles and side lengths are distributed is because this first triangle here we can actually find by splitting in half an equilateral triangle, right? So you don't need to actually remember this, the equilateral triangle thing, for any content, but just like to actually help you remember what the triangle looks like. So if we have an equilateral triangle, we know that this angle here needs to be 60, but this angle here needs to be half of that because it's been split in half. And this is what we see here, 30 and 60. Then of course, this side is unchanged, so it's going to be 2. It's going to be the biggest number. However, it was an equilateral triangle, so this whole length is 2, but it's now been split in half for this triangle, so this is only 1 now. And then using Pythagorean theorem, a squared plus b squared equals c squared, we know that this height here is root 3. Alright, that is just how I remember where all of the lengths and angles go. Now getting on to our next triangle. This one is also a right angle triangle, and it has equal sides, both length 1 and a hypotenuse root 2. Because these sides are equal, both angles are 45 degrees. Alright, so as you can see, using these triangles, we can find the sine, cos, and tan of angle 30 degrees, 45 degrees, or 60 degrees. So say we wanted to find the sine of 60 degrees, right? We can go here is the 60 degrees. Sine is equal to the opposite over the hypotenuse. So we're going to have the opposite of 60, root 3, divided by the hypotenuse, which is 2, which gives us the sine of 60 equals root 3 on 2. So as you can see, this table of values here describes what you can find using these special triangles. Another example is if we wanted to find the tan of 45, we would have the opposite over the adjacent, which would give us 1 over 1, which gives us 1.